Hey everybody, welcome to the Student Success Commons video, a brief overview of the metric system. So in this video we're going to look over how the decimal system works and how this compares to the metric system prefixes, as well as units and quantities. There are several different base units, but in this video we're just going to focus on meter, gram, and liter. We'll also go through a few examples of the types of problems you may encounter in your math class, especially in something like dosage calculations or pharmacology. We're going to look at common metric measurements, how to convert from smaller units to larger ones, and then vice versa, although not necessarily in that order. First things first, though, we need to cover the basics, or the bases. We need to look at the base 10 number system. So in everyday life, we use a base 10 numbering system, the decimal system. You're familiar with it, you've seen it. When you go look at gas prices, you're seeing numbers represented in base 10. When you buy something at the store, your receipt shows you numbers represented in base 10. It's what we use in everyday life. There are other bases, like base 2 or base 6, but you're probably never going to deal with those unless you're in computer sciences, in which case, good for you. But we're going to stick with base 10. And in the base 10 system, the position of a digit is called its place value, and it determines its value, how much it represents. Alright, here's a small decimal system place value chart. You've probably seen this before, and you're probably familiar with ones place, tens place, tenths place, especially if you've taken any kind of math ever before. This chart's actually going to be pretty helpful because there will be several times when you're asked to round to the tenths place or the hundreds place or something like that. So make sure you're familiar with the decimal system place values. So like I said before, we're all used to this system, but just as a quick recap, we're going to look at the numbers 675 and 21 hundredths. So I'm going to start from right to left, reading this number, or at least explaining this number, and the first thing is the 1. The 1 is in the hundredths place, which means I have 1 hundredths. Then we have the 2. That's in the tenths place, so I have 2 tenths. Then we got the decimal point. Then we have the 5. 5 is in the ones place, so I have 5 ones. Then we have the 7. The 7 is in the tens place, which means I have 7 tens, or 7 times 10, which is 70. And then we have the 6, which is in the hundreds place, or 6 times 100, which is 600. So that's how altogether we get 675 and 21 hundredths. So as you move to the left in this chart, the value is 10 times larger than the place to its right. If you move in the other direction, if you go to the right, the value is 10 times smaller than the value to its left. Place values in the decimal system change by powers of 10. Here's that same place value chart showing the powers of 10. Digits in the ones place are really multiples of 10 to the power of 0. Digits in the tens place are multiples of 10 to the first power. Digits in the hundreds place are multiples of 10 to the second power. Similarly, on the decimal side of the chart, place values change in the same fashion, just with negative exponents. The negatives sometimes do confuse people, but know that negative exponents don't mean negative numbers, they just indicate a fraction, a decimal. Like I said earlier, you're definitely going to want to be familiar with these places. It's handy to know how the powers of 10 work. It's especially if you are going to do any extra math studying, it's going to be very useful because there's a very clear relation between the powers of 10 and the metric system. But if you aren't super comfortable or familiar with exponents and powers of 10, don't freak out too much. It's mostly in this video just to show you the relationship between the two. It's not something that you're ever, well, probably, going to actually have to know from scratch or learn from the ground up, so don't worry about that too much. At the end of the video, we will go over things that you will definitely want to know. One of them being, like I said, the place values. There are going to be times where you're going to be asked to round to the nearest tenth or the nearest hundred. So not only will you need to know what the place values are, but you're going to want to be familiar with how to do proper rounding. And a lot of us maybe have been out of practice for a while, so there's a link in the description to a worksheet that covers rounding and place values. So if you need some extra practice with rounding, I highly recommend that you download it. Okay, before we go and dive into the hot topic of the video, let's take a second to make sure everyone is familiar with what units and quantities are in just general mathematics. So a unit is a general term that means the type of measurement. We're going to look at the base units of meter, which measures length, gram, which measures mass, and liter, which measures volume. Quantity is essentially how much there is of something. Now both of these things, units and quantities, can be explored more, but for the purposes of our video, we're just looking at it in this context, and we're just going to be looking at those three base units, meter, gram, and liter. We'll come back to those in a minute. Okay, now it's time for the good stuff. Now we can get into the metric system of measurement. So this isn't probably something you're going to be quizzed on, but I think it's kind of interesting. So you see all these countries in blue here. These are the ones that officially have adopted the metric system and generally use them mainstream. The ones in gray, there's only 3 of them, are the countries that have not officially adopted the metric system for mainstream usage. So the US being one of those 3, we use the imperial system. We use pounds, feet, inches, miles, cup, etc. But we do use the metric system in sciences. That's kind of unavoidable, and that's why we're here. Okay, so remember that chart I just showed you of the place values with the powers of 10? I showed you that because the metric system is based on powers of 10. The metric system also makes use of prefixes that describe how much bigger or smaller a particular unit is than the base unit. Remember, the base units we're going to look at are meter, gram, and liter. Alright, so there are a whole bunch of different prefixes. Here are a couple of the common ones. Kilo, that's one of the most common ones. Centi, milli, and micro. Those ones I think I see come up the most. All of these prefixes can be combined with any of the base units. So you could have a kilometer or kilometer. You could have a gram, which is a base unit, or a microgram, or you could have a centigram, or a centiliter. Basically, you can combine any of these prefixes with any of the bases to indicate that you're measuring something larger or smaller. Alright, we're back to the powers of 10 now. Each prefix represents a particular power of 10. Kilo means 1,000, and 1,000 is 10 to the third power. You can check that back in the graph of the place values with the powers of 10. So kilo means 1,000, which means a kilogram is 1,000 grams. Kiloliter is 1,000 liters, and a kilometer, or kilometer, however you want to say it, is 1,000 meters. On the other end, we have micro. Micro means 1 millionth, which is 10 to the negative 6th power. Again, that's on the chart from before if you want to go back and look at it. So if you have a microgram, you have 1 millionth of a gram. A microliter is 1 millionth of a liter, and then a micrometer is 1 millionth of a meter. So, like I said, all of these prefixes, they all are based on powers of 10, and they can all be combined with those base units that we're going to be working with to indicate different measurements. So, because the metric system takes advantage of our base 10 number system, it's very easy to convert from one metric unit to another simply by multiplying or dividing the given number by some power of 10. You can see here I've lined up the prefixes that were on the previous page. I've lined them up on the decimal system place value chart that we had earlier. You can check that out here. See, they line up pretty nicely. And so that's what we're going to do when we do conversions. It's literally just multiplying or dividing by either 10 to the first power, or 10 to the third, or 10 to the negative second, depending on what the case may be. But I will show you a shortcut for this later. But I just want you to see how they line up and how they are so similar, and that's why math is cool. I'm sorry, I'm gonna geek out for a second, but math is so cool, man. Things relate in the best way ever. So, okay, moving on. Alright, so by this point I've repeatedly mentioned meter, gram, and liter a few times. But if you haven't used these units very much, it might be helpful to visualize them. So let's look at them. So meters, they measure length. So 1 meter is about the width of a typical doorway, which means if you wanted to design a doorway for a mouse, you might make the opening only about 1/10 as wide, which would be a decimeter. Alright. Gram measures mass. So a regular paperclip weighs about 1 gram. This means if you had 1,000 paper clips, you would have about a kilogram, since kilo, remember, means 1,000. If you have a very large bottle of shampoo, it might hold about 1 liter. So if your big shampoo bottle has enough shampoo for you to lather up 100 times, that means that each time you would use about a centiliter, or 1/100th of the original volume, since centi means 100th. Now I've used the prefixes here a couple of times. I know they may still be new to you, so it would be probably a good idea to make a printout of what the prefixes are and what they mean, and just practice using them, get used to seeing them and hearing them. Like I said a minute ago, there are quite a few prefixes that are in the metric system, and I have not shown them all, and I'm not going to show them all, because really there are only a few that you are probably going to come up against in your homework and your assignments, and they are the ones I've shown here. So these 4 here, the kilo, centi, milli, and micro. Those are the 4 most common ones that I've come across anyway, so we're going to focus on those. Each of those prefixes has its own symbol, and it does matter if the symbol is capital or lowercase. Just keep that in mind. And just to recap, kilo means 1,000 times, which is the same as 10 to the third. Centi means 1/100th, or 0.01 times, which is 10 to the negative second. Milli, is 1/1000th, which is 10 to the negative third. And then micro is 1/1,000,000th, which is 10 to the negative sixth. Now, don't forget, like I said, we're going to be working with meter, gram, and liter, and all of these prefixes can be combined with them to get different measurements. Like you can combine the kilo with the meter to get kilometer, which would be represented with km. Or you might see micro and gram, which would be the mcg, because gram is represented with a G. So you're going to see a combination of all the symbols. Here's a secret for you that I've discovered. Mathematicians are really lazy, I think, and so we abbreviate everything. So why write word when you can use letter? So now it's time to work on some practice problems. Over on the right here, as you can see with my cool laser pointer thingy that I didn't know PowerPoint had, over on the right here is a simplified version of our metric prefixes chart. I've left out the ones that we won't use in these examples, but we do need our prefixes to stay in order to ensure we're multiplying or dividing by the correct power of 10. So that's why you see a few blank spots. These are just placeholders for the units that we're not going to be using. So we're not ignoring them exactly, we're just not going to use them. So when using this chart, we'll divide by a power of 10 when you move upward, and we will multiply by a power of 10 when you move downward. Let me show you what I mean. So for this first problem, we have 1 km. Now k is kilo and m is meter, so that means we have 1 kilometer. And we are looking to convert that to meters. So let me grab my pen. This is going to look hideous, but hopefully still legible. So I'm going to start on the chart with kilo. That's my prefix, kilo. So I'm starting here, and I'm going to count how many spaces I have to go down to get to meter. And remember, meter is a base unit, so I'm going to have to go from kilo to the base. So I'm going to have to go down 1, 2, 3. I moved down 3. Down 3. Yep, that's my handwriting. And according to the chart, it says if you move down, you have to multiply. And what do you multiply by? The power of 10. So we're going to multiply by 10 to the third power, because we moved 3 spaces down. So we're going to do 1 kilometer times 10 to the third power. You can grab a calculator if you'd like. I just figured out the laser pointer, so I have no idea how to do a calculator. But you can go ahead and grab your calculator and follow along with me if you want to. If we do 1 times 10 to the third power, we should get 1,000, which means 1 kilometer is 1,000 meters. So here's our next example. We have 1 m. M is meter, which is a base unit. So we're starting at the base, and we have to go to km, kilometer. So I have to go all the way up to kilo. So I have to go up 1, 2, 3 spots. It didn't look very good, but I'm moving up 3. So I moved up 3. And according to the chart, you divide when you move upwards. Divide. So we're going to divide by, again, a power of 10. We're going to divide by 10 to the third power because we moved up 3 spaces. We're going to do 1 divided by, that's 1 meter, 1 divided by 10 to the third. And we should get 0.001 tenths, hundredths, thousandths. We should get 1,000ths of a kilometer. Okay, so what happens if your unit isn't, if it's not just 1, if your quantity isn't 1, and you have something like 2? Well, let's see what we do. So I have meter, my base unit. I'm going to kilometer, so kilo. So again, I've got to go up 1, 2, 3. So up 3. And remember, when you move upwards, you divide. So I'm going to divide by 10 to the third. So I'm going to take 2 from the 2 meters and divide by 10 to the third. Again, if you got a calculator, go ahead and give this a shot. And we should get 0.002. We should get 2 thousandths. So it doesn't really matter what the quantity is, if it's 1 or if it's 10 or if it's 2 or it's 5.5, whatever. You still use the same process. You figure out where on the chart you start, whether it's the base or millicenti, whatever, and you determine how many steps you have to move up or down to get to the next correct prefix you're trying to convert to, and you just do either multiply or divide. We'll do a few more. We'll do a few more examples though. So let's say we have 2 meters and we want to convert that to centimeters. Now meter again is a base, m, meter, base. Got it? Okay, so base. We're going down to cm, c is centi, so we're going to go down to 1, 2. So we move down 2 spaces. So down 2. So that means we have to multiply by 10 to the second power. So that means I'm going to take 2 from the 2 meters and multiply it by 10 to the second power, and I should get 200. So 2 meters is 200 centimeters. Alright, let's take it up another notch with this one. So we have 2.5 meters, and we're going to go to kilometers. Now meters, again, this is a base unit. I'm going up to kilo. 1, 2, 3. So we're going up 3. And this chart says divide if you move up, so we're going to divide by 10 to the third. And it's no different than the previous ones. Even though I have a decimal here, it's still going to work the same way, especially if you're using a calculator. We're going to take 2.5 and divide it by 10 to the third. Now, if you learn the trick about how to move the decimal point to the left or the right when dividing or multiplying by 10, go for it. You can use it. You can use the calculator. Doesn't really matter, as long as you get there. So, anyway, back to this one. So 2.5 divided by 10 to the third power, we should get, oops. Well, I don't know how to undo that, so that's going to be our decimal point. 0.00. Yeah, it fits. So we should get 0.0025. That's tenths, hundredths, thousandths, 10,000ths. We have 25 10,000ths for this one. Let's keep going. Alright, so let's do one that doesn't involve the base this time. So let's say we have 5.5 millimeters, and we have to go to centimeters. So we're starting at milli and going to centi. We only have to move up once for that. So we had to move up once. One time, whatever. And again, if you're moving up, you divide if you move up. So we're going to divide by 10 to the first power, which is really just 10. So we're going to take 5.5 and divide it by 10. You can keep the exponent in there if it makes you feel more comfortable, or you can leave it off. It doesn't matter. Either way, you're going to get 0.55. Okay, let's end our examples with a big one. So let's say you have 19,000 micrograms, and you need to convert that to milligrams. If you are a nursing student, you will probably see something like this. So let's do it. So micro down here. Now there are two symbols for micro. You might see MC or you might see the Greek letter mu. I think I see MC more often, but either way, they both mean micro. And we're moving up to M, milli, so moving 1, 2, 3 times up. So up 3. And it says multiply if you move, divide if you move up. So we're going to divide by 10 to the third. We moved up 3 spaces, so our exponent is a 3. So 19,000 divided by 10 to the third is just going to get us 19. A much more reasonable number, if you ask me. A couple of examples. Let's move on to the wrap up. Let's make sure that you know what you really want to take away from this video. Okay, so here are the takeaway points that I want to make sure that you leave the video with. We talked about base 10 and powers of 10 and negative exponents and all that stuff. And all that stuff is really cool, says the math tutor. But what I really want to make sure you keep with you is that although there are many base units in the metric system, some of the most common ones are meter, which measures distance, gram, which measures mass, and liter, which measures volume. If you are interested in some of the other units that are used in the sciences, there's a link in the description you can check out. You might be surprised to see some units you already use quite often. Another takeaway point is the chart that we used in these previous examples. I highly recommend that if you're not super comfortable converting from units already, print it out and keep it in your notebook, your binder. Put it in one of those plastic binder sheets. That way you can use a dry erase marker to actually do calculations on and do the little circle and count and the method that I use there if you'd like. Putting it in one of those plastic sheets lets you use a dry erase marker and use it over and over again until you get comfortable. Eventually you'll get to the point where you're like, oh yes, I know I have to divide this by 10 to the third or 1,000 or whatever. But until you get to that point, I recommend using a chart and doing more practice problems for yourself. I do also want to point out that you can't use the method that was shown in these problems to convert from like kilometers to liters. Those are two different types of measurements, so conversions would be different. But don't worry, that's not something you have to do anyways. You would probably only have to convert within the same type of measurement like we did in our problem, so don't worry about that, but I did want to put that disclaimer in there. And finally, the last thing I want you to take away is that there are a whole bunch of additional math resources if you visit the SSC online or in person. We provide support for dosage and pharmacological calculations, converting all sorts of units beyond the ones that we showed in this video. We have material for statistics, trigonometry, finance, pretty much anything. The link I have shown here on the screen, virtual.yccc.edu/student6common/conversions. I know it's a mouthful, but it brings you to our main conversions page, which shows you conversion factors for a whole bunch of other things, some of which will come in handy in your classes, like if you need to convert from hours to minutes or, I don't know, pounds to kilograms. We have charts for that, but we have, like I said, we have resources. Well, so close to the end of the video and I stopped being able to talk. We have resources for a whole bunch of other things, so please feel free to visit us online or in person or reach out to the Student Success Commons if you need any support with math. All the links are in the video description, and I hope you enjoyed or at least didn't hate this video. I look forward to seeing some of you in the SSC.